To my channel again. This is Teacher Atari. In our previous lesson, we discussed what is known as the periodic table, and we said this periodic table is an arrangement of elements according to atomic number, and we were told that this periodic table have what is known as the period and the group. The group is arranged according to atomic number, and these periods, the number of shares this element occupy, determine their period. They were placed in the periodic table. And we said the group 1 element, we have said group 1 element, group 2, group 3, group 4, group 5, group 6, 7, 8, or 0. We said this element, they are arranged in this format. We said between group 2 and group 3, we have the 10 blocks known as the transition metals. So in this aspect, we said this number of groups determine the number of valence electron. The last shell, they occupy valence electron. In the cell will be group 1, they contain 1. The group 2, they have 2 valence electron at the end. So what actually happened here is that this element is trying to achieve what is known as doublet. They are trying to obtain what is known as doublet or octet structure. Octet structure. And we said the group 8 element is known as octet structure because they have 8 electrons in the atomos shell. So all these elements that is having these electrons in their atomos shell, they plan to be stable in all the activities to achieve what is known as octet structure or doublet structure. So what happened here is that for this element that have 1, 2, 3, 4, 5, 6, 7, their aim is to be stable. So the stability in chemistry is that they want to have 8 electrons in the atomos shell. That is to say, for this element that do not have 8 electrons in the atomos shell, from here to this, they tend to undergo a combination known as chemical combination so that they will achieve what is known as octet structure. So this will take us to the meaning of chemical combination. What we mean by chemical combination? These atoms or chemical elements, they come together to become stable with the aim of becoming stable. And when we talk about stable, they want to have this doublet or octet structure. So what do we mean by doublet structure? We said in our periodic table we use electronic configuration to arrange this element on the table. We said this for element to have this fifth shell, to have these 2 electrons in the S shell. That is to say that such element have a doublet filled shell because this electron is filled up. This block is filled up. According to Album, we said we have SPDF. This SPDF tells us about the blocks in the periodic table that I've emphasized in our previous lesson, that we have the S block, we have the P block, we have the D block, we have the F block. We said this F block is the 6th and 7th period. On the periodic table, we said this D is the transition metals. The metals that falls between the group 2 and group 3, the 10 blocks that started with scandium and zinc. So we also talk about the P blocks. We said the P block is between group 3 to group 8. It contains the metals, the non-metals, and the metalloids. We said the S blocks contain the group 1 and the group 2. So by so doing, we said the maximum electron this S can take is 2. We said the maximum electron P can take is 6. The maximum electron D can take is 10. The maximum electron F can take is 14. Is 14. That is to say that the maximum electron of each of these is written as this. So we said this S block, if for any atom or element to achieve this to have this filled S block, that the maximum electron it can take is 2. That such element have occupied what is known as doublet structure. Known as doublet structure, to obtain what is known as doublet structure. Like the hydrogen that is 1, its aim is to become doublet structure, to become a nucleus of helium. That is to say, every element in the periodic table, they tend to come together to achieve this 8 group electronic configuration. That is to say, element in group 1 to 2 undergo a reaction or combination to have to have filled 8 electron in the atomic shell. So in a normal sense, when substances or elements, when they come together to form this stable compound, is known as chemical combination. So in this aspect, this takes us to the types of chemical combination. So we have 2 types of chemical combination. We have the covalent. Let's start with the electrovalent. Electrovalent combination or bonding. We also have covalent combination. Covalent combination. Covalent combination is divided into 2. We have the ordinary covalent, and coordinate covalent. Coordinate covalent. So in this, you're going to dive into the first subheading known as electrovalent combination or bonding. So what happens in electrovalent combination is a very simple way. It occurs between this group, mostly group 1 and group 2. So in this aspect, we say this in this regard, we define electrovalent bonding as a process through which there's a transfer of electron from a metal to a non-metal. That is to say, a very good example, we have sodium, that is a metal. The electronic configuration of sodium is 281. The electronic configuration of this non-metal is chlorine. We have 287. In this aspect, every element, as I've explained, they tend to be stable. That is why they undergo what is known as chemical combination. When they come together, to form a stable compound. So in this now, we say sodium have 1 electron in the atomic shell because it's placed in group 1. In this aspect, this 1 electron will be transferred to this chlorine because this 1 electron is not needed by sodium. Sodium is 10 in any given chemical reaction. Sodium tends to be stable. That is to have this 8 electron. So you want to have this tendency of having octet structure, like the group 8 element. So by so doing, whenever you see any possibility of releasing this electron, it gives us this electron with ease. So in this aspect, we're going to use the electronic configuration to explain this concept properly. I'm going to use this electronic configuration to explain this concept. Let's use sodium. Let's use the electronic configuration of sodium. We have electronic configuration of sodium is 2. We're going to use the last shell. The last electron is here. I said the first. This is the K. This is the L. The M shell is having only 1 electron. That is to say, this is sodium. Chlorine. Chlorine is, we have let's use the electronic configuration 2, 8. I'm going to use this 7 electron around the system. So what happened during this chemical reaction or combination? These electron from this sodium is transferred to the chlorine. So what is formed at the end? We have sodium that got transferred, that transferred this 1 electron to chlorine. So we have one of the electron here. This one is transferred to this to make it 2. So what is formed here is known as ions. Ions are formed. We have the positive sodium ion and the negative chloride ion. That is to say, in electrovalent combination that involves a metal and a non-metal and there is a transfer of electron, we said what is produced at the end of the combination is ions. Since ions are present here, we will say that there is these compounds can go to some extent that they can conduct the electricity because there's a moving ions in the system. So according to ionic theory, when this system they have these moving particles, it tends to dissociate, and when they dissociate, it gives a moving particles known as ions, and this ion they can conduct electricity. So in this aspect, we are going to go for another example. We said one of them, we said formation of sodium chloride. Formation of sodium chloride. It's a very good example of electrovalent bonding. So the other example we are going to go for formation number 2, when magnesium react with magnesium, formation of magnesium oxide. That is to say, let's use the electronic configuration of magnesium. Magnesium is 12. We are going to use magnesium is 2, 8. It has 2 electrons in the atom shell. That means we should have an oxygen here. And oxygen is 2. It has 6 electrons in the atom shell. That is to say, when they react, these 2 electrons is transferred automatically to oxygen. So what is produced at this end? We said magnesium 2, 8. That's 2 here. We have oxygen 2, 6. So what is there? This is transferred to this. Here become 2, 8. Here became 2, 8 as well. So the essence of them coming together is to form a stable compound. That is to say, we have here, we have the positive ion and we have the negative ion. What is formed there is magnesium 2 plus. We have oxygen 2 negative. Here in electrovalent combination, we cannot conclude that we must have a donor. And an electron acceptor. Like that is a donor. From a characteristics of a metal, they donate an electron to the acceptor, which is known as non-metals. So what are the major characteristics of this electrovalent compound that are formed? As I've said before, since they have ions, they do what? They do conduct electricity. Characteristics of these electrovalent compounds. The characteristics. So we have known that in electrovalent combination there's a transfer of electron. So in this now, what are their characteristics? One of their characteristics is what? They conduct electricity. Because there's the presence of moving ions in the system. We said 2, they are soluble. They are soluble in water. So 3, they are solid. At room temperature. That is to say, for us to have a better understanding, we said chemical combination is obtained when these elements that do not have this octet structure tend to come together to form this octet structure so that they will form a stable compound. We say we have two types of this bonding. We say we have the electrovalent, and we say the electrovalent, there's a transfer of electron between a metal and a non-metal. And what is formed at the end of this reaction or combination? Ions are formed. Since ions are formed, they conduct electricity, they dissolve in water, and they are always found at solid in room temperature. So in this aspect, we are going to move to the next topic. The next topic is covalent. We are going to talk about covalent. Let's talk about ordinary covalent. Ordinary covalent combination. In this aspect, we are going to talk about more about this group 4 element. Let's say group 4, group 6, group 5, group 6. since these elements they tend to have this octet structure known as 8 electron, the possibility of getting to this 8 electron within this group is very close to 8. That is to say, if parameter there's a chemical reaction, you will not expect carbon, for instance, to donate this 4 electron to a new element that tend to have a octet structure. By so doing, this 4 electron of carbon will be what? Will be withdrawn, will be held together by carbon, so that it will be looking for a way to have more 4 so that it can become stable. That is to say, this from 4, 5, 6, they cannot transfer their electron. For instance, now you are given a task of making it to 1,000 naira as a student, and for instance now you have 500 naira, and someone that have 100 naira. Let's say someone have 100 naira, student A have 500 naira, student B have 100 naira. There's a possibility for this B student to give out this 100 naira, because the possibility of making it to 1,000 naira is very, very high compared to this 500 naira. With this aim of this student, there's a possibility of making it to 1,000 naira. So for this such person to release this 500 naira easily in a given task will be very, very hard. But the one that is having 100 naira, it will be very, very easy to give it out, because the possibility of making it to 1,000 naira within the target period is very, very high. That is to say, in this now, this 4 electron is present in group 4, group 5, group 6. They do not transfer their electron. They share their electron between participating chemical reactant. When they share this reaction, this aspect, we are going to they give out a stable compound. That is to say, in an ordinary covalent combination, electrons are shared between participating reactant. Electrons are shared equally between participating chemical reactant. Between chemical reactant. That is to say, this electron that is being contributed, they all being shared. They share the same. If for instance, one of them brings 1 electron, the other one will bring 1 electron. If this other one should bring 2, this one will bring 2, so that they will come together to form a stable compound. In this aspect, I'm going to introduce you to keywords we're going to use in this ray guide. We're going to talk about one. I'm going to talk about shelled electron. I'm going to talk about lone pair of electron. So we said in covalent bonding, we said there is a sharing of this electron, and this sharing of this electron give birth to what is known as what? Shelled electron. For instance, now let's talk about an element like hydrogen have only 1 electron. Let me explain this concept. Hydrogen atom have 1 electron. So for this atom, we say atoms are not stable. They will look for another atom which is a similar atom with hydrogen here. We'll look for another hydrogen to react together to form covalent bonding. And by so doing, we say we have here, when they come together, they share these electrons together. So this electron that is shared together is known as shared pair. Shared pair of electron. So we are now moved to lone pair of electron. Lone pair of electron is obtained. This lone pair, they do not participate in the existing chemical combination or bonding. So by so doing, they are known as lone pair. For instance, let's use hydrogen. Okay, let's use this hydrogen here, and we have oxygen. Oxygen is 2 here. We say let's have, it has 6 electron in the outermost shell. So when they come together, if I should have, I'm going to have something this way. In this regard, I'm going to have one of these chair will be given. This one will be attached to one of the hydrogen. Here will be attached to one of the hydrogen. Here I'm going to have two electrons here, two electrons. These ones that do not participate in this chemical bonding, they are known as lone pair of electrons. So what do you mean by lone pair of electrons? These electrons do not participate in the existing chemical combination or bonding. That is the meaning of lone pair of electrons. If that is clear, we're going to move to the examples on ordinary covalent bonding. Ordinary covalent bonding. We say in ordinary covalent bonding, this shared electron is contributed equally by the participating chemical element. That is to say, very good example is the formation of hydrogen molecule. Hydrogen molecule, as I've said before, we said hydrogen atom have only one electron. We have here it has only one electron. So when they come together, they form a molecule which is H2. They form, one of them contribute one of the electron, one of them will contribute this electron. As I've said, this one that is contributed, they are known as shared pair of electron. So by so doing, we also talk about another example of covalent combination, ordinary covalent combination. We'll talk about formation of chlorine molecule. That is to say, we have, for instance, let's say chlorine is 2, 8, we have the 7 electron here, plus we have here we have chlorine 2, 8, the 7 electron is spread this here. So in this now, they will now come together. So this one of the electron is contributed, one of this is contributed, while the other electron is spread out. That is to say, each of these chlorine atom have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. This chlorine atom in the other end have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. In this aspect, we said chlorine molecule is formed by covalent combination. So one of the chlorine contributed 1 electron, this contributed 1 electron. So in this now, for time's sake, we are going to move to the characteristics of ordinary covalent combination. Since at the end of covalent combination, what is formed at the end is a molecule. One of the characteristics is that they do not conduct electricity because there's no moving ions in the system. So one of the characteristics of ordinary covalent combination is that they do not conduct electricity. We say characteristics of coordinates. Pause.